Welcome viewers to my channel. Today there is a class of about some important properties of defining integral. Here is the 8 point of properties, okay, now which I discuss about these 8 points for integral calculus. Now first point here is if the limit be a to b f of x dx, okay, there is a variable x, and see on the right hand side there is a limit a to b also, but variable are different, so both are equal, and from that if one, that is a to b f of x and dx, and let us assume the function of f of x when it is integrated, then integral result is, let us assume that is capital F of x, okay, and we can put here lower limit is a and upper limit is b. So now see f of b minus f of a, and again on the right hand side, this is left hand side, okay, and on the right hand side see a to b and same function, but variable here is z, so we can write here, so capital F of z, okay, capital F of x, and this is with respect to the variable of z. So similarly we can put here as f of b minus f of a, so both the results are same. So in this case we can say that both the integral are same, so one number property are proved here, okay, it's proved here, okay. Now for the question number 2, property number 2, see that is a to b and f of x and dx. This is lower limit and this is upper limit, which are a to b here, but I want to write like that, a to b, that is f of x, this is not a to b, this is b to a. If we write here minus, so limit are changed, lower are changed to upper, upper are changed to lower, okay, that is f of x dx. On the left hand side, same as, assume that the integrand function is f of x here. If we integrate, then we get, if we get the result capital F of x, our limit here is a to b, then capital F of b minus f of a here, okay. On the right hand side, that is minus b to a f of x dx here, same as the integral result here is capital F of x on the indefinite, and put here at the limit b to a, then we got f of a plus f of b here. So see both the results are same, so you can say easily both are equal. So number 2 property is proved here. If a or b are the limit here, a to b, this is a to b, sorry, this is c, and this is equal to a to b f of x dx. In between a to b, if c lies, then the integral are split by this method, like a to c then c to b, a to c then c to b f of x dx, okay. And similarly you can show also the third property, that is a to b f of x dx can be written as a to c f of x dx and c to b f of x dx, and let us assume a to b, let us assume the integrand be f of x dx is capital F of x and c1. So on the left hand side, this is left hand side, which I get here f of x and dx, result is f of x, so this is a to b here, so f of b plus, sorry, this is minus f of a here. On the right hand side, similarly we can write a to c and f of x dx, that is c to b f of x dx. So result is f of x So that is limit is a to c, and also result is f of x. The limit is c to b here. So you can easily put f of c minus f of a, and on the second part, that is f of b minus f of c here. Okay, and c are cancelled. Then you left here f of b minus f of a. So these are same. So you can say the third number property are equal and verified. And now question number property number 4. This is a very important property. This is a very important property. See the proof. Okay, see that clearly. This is the most important point. And now see the fourth property. This is the fourth property. Okay, see 0 to a f of x dx, and that is equal to 0 to a. You can write here a minus x dx. On the right hand side, f of a minus x dx here, we take assume a variable, that is y is equal to a minus x here. If we differentiate dy dx, and that is equal to minus 1, so dx is equal to minus dy, and changing the limit, the value of x, the limit of x and limit of y here, the limit of x here 0 or a, okay. If we put 0 on that, then we got a. If we put a, then we get 0. So from this here, limit of change a to 0 here, and f of y and dx is minus dy, see, okay, and this is minus a to 0 and f of y and dy. We can write 0 to a, this is minus, and this is the property number, we use the property number second. If a to b f of x and equal to minus b to a f of x dx. Just discuss the second point. Okay, so here is minus. We can write here plus a to b, and we can write here 0 to a and f of y and dy. And also right here, if the variable be a to b f of z dz, we can write a to b f of x dx. Any variable, f of m dm, any variable, f of y dy. Okay, and here 0 to a f of y dy, you can write here 0 to a. Okay, this is the fourth property is verified. Okay, now the property number 5. See, there is a restriction. If a function f of a plus x is equal to f of x, what is the relation between and the limit? See, a plus x equal to f of x, and there are the n into a. See, if here is given that the 0 to pi, if there are 0 to pi, and pi can be expressed as 2 into pi by 2. If that satisfies the function pi by 2 plus x is equal to f of x, then you can write, and this is here 2 into 0 to pi by 2 f of x dx. Okay, so this is the main important point. Now okay, see the point number 5, 0 to n is an integer, and f of x and dx here, which this integral is split from 0 to a f of x dx, same as a to 2a f of x dx, same as 2a to 3a f of x dx, plus dot dot dot, and that is na, and so n minus 1 into a, and f of x and dx we can write here. So there are the nth integral, first, second, third, dot dot to the number of integral here is nth. Okay, n, and let us assume each of integral are equal to that, and for these are all equal are 0 to f of x dx here. If the function are satisfied a plus x is equal to x, okay, now see, for a to 2a, just I have to want to prove this point, then other integral are commonly proved here, okay. Now f of a to twice a f of x and dx here, okay. And let us assume a function variable y, and that is a plus x, okay. So if we derive it, dy is equal to dx. So changing the limit here x and y, that is a to 2a. If we put here a, sorry, there is a I think that is this is equal to x is equal to a plus y here. There was wrongly written, and if we put and if we put here a, then you got 0. If we put here twice a, then you get a. So the limit here is 0 to a, and again x is equal to, that is f of a y, and differentiate this, then dy. And from the first property we have right here 0 to a, f of a plus x and dx also. So we have written 0 to a, and f of x plus a is equal to f of x here. So okay, samely we have to written, and for the point all are equal. So 0 to na f of x and dx is equal to 0 to a f of x dx. So this is equal to this 0 to a f of x. Same as this integral also proved, can be proved a 0 to a f of x and dx also, and all are equal. So 0 to a f of x and dx also. So we can write, this is the nth number of integrals. So we can write the n times of single integral 0 to a f of x and dx here, okay. All are dx here. Okay, this is the important point, and just see the verification. Okay, now we have to prove the question number 6 and point number 6 here. See, and this is same point related to 5 here, and here 0 to 2a and f of x and dx. And see that carefully which I follow the procedure, students. Okay, this is the formation. If there are the twice a f of x dx, 0 to twice a, and we can write here 0 to a f of x and this. Okay, now we have to follow the property. Just we have to prove here 0 to a f of x, as we see 0 to twice a, there is limit, and another point let us assume in between twice a, that is a. So we can split the integral like 0 to a f of x and dx, and a to 2a and f of x dx here, okay. Now the limit here is 0 to a, and this also is 0 to a, okay. Now we also convert this integral as a 0 to a, and then we have to take account the integral 0 to a f of x and dx, and we got the in between the function. Okay, now let's see how can prove this. Okay, this is the formation. We want to get here 0, so we can take a function like y is equal to take a function x is equal to twice a minus y here, okay. If we put here a, if we put here 0, okay, very good. Dx is equal to, and that is dy, okay. And now look here, if we put the lower limit as the a, then we got a, and if the upper limit twice a, then you got 0 here. And f of x, x means that is twice a minus y, and differentiate this, we got here dy minus dy. So there is minus, so limit are changing from 0 to a here, and f of twice a minus y dy here, okay. And now simply we can write 0 to a and f of twice a from the first rules, f of x dx here, okay. Now see, you can see this is 0 to a f of x and dx, and from this relation from this equal to this we have right here, that is we can 0 to a f of twice a minus x dx, and both the limit are same, 0 to a can write as a single integral, that is 0 to a, and take addition f of x and f of twice a and minus x dx, okay. This is the most important point which I have discussed here, so see that carefully. And now we want to discuss the 7th number point, and this is also very important, and also 8, okay. And then after we shall some discussion about some problem. And now see for the question number 7 here, see the limit, and same procedure you have to follow here, a to minus a to a, and f of x dx, and simply that is minus to minus a to a, in between them there is a point like 0, so this integral are spreading by 0 to a, 0 to 0, minus a to 0, and f of x dx here, and also 0 to a and f of x dx here, okay. So now there was a limit 0 to a here, so this is fixed, and now we want to change like both are same limit 0 to minus a here, okay. Minus a to 0 f of x dx. Take a variable like x is equal to minus y here, okay, and dx is equal to minus dy, you can write. And now simply we have put the limit lower limit here, then we got y equal to a here. If we put 0 here, then we got 0 here, and then f of x means that is minus y here, and d is equal to minus dy. Simply there is a minus, so we can change the limit here 0 to a, and that is f of minus y and dy here, okay. And from the first rules which I had discussed in the first point, 0 to a, and we can write here minus x and dx. So on the right hand side, this is the right hand side, and this is the right hand side, we can write here like minus a to 0 and f of x and dx, and also 0 to a f of x and dx here. So see, and this is can be written as 0 to a and f of minus x dx, and 0 to a and f of x and dx. So that is 0 to a, this is 0 to a, 0 to a, this is both the point are same. So now we have written here like f of minus x plus f of x here, we take a common integral like this, okay. If the function, carefully see there, if the function be odd, then f of minus b is equal to minus f of x, so there will be a 0. So 0 when f of x is an odd function, okay, and this is equal to twice time of 0a, that is f of x dx. If f of x is an even function, okay. So last point, that is 8. This is the most important point also here. See the last point carefully. See the last point here, 8, and that is a to b and dx here, that is equal to a to b. You can write sum of the upper and lower and minus x and dx here, and we want to write here on the right hand side, prove here right hand to left hand side there, okay, a minus x, a plus b minus x here as a y. So differentiate this and we get this, okay. If you put lower limit in this, then you get lower limit bb here. If the upper limit bb, you put here bb are cancelled, so upper limit here is a. So, and that f of y here and dx is equal to, that is minus dy. And see, this is minus, we can change the limit here to b. and f of y and dy here. And now a to b, we can apply the first rules, and that is, and we can write here, oh sorry, here f of x are missing there. Okay, this is the question number 8. Okay, now the discussion about some problem with the help of these 8 points. And now see, for the question number 1, let us assume as a I, and that is 0 to pi by 2. This is the number 1 question. 0 to pi by 2 root sin x dx, and by and root over cos x and plus root over sin x there. We have to use the formula for the point number 4. This is a very important point here. Okay, now right here, and 0 to pi by 2, and we have to written like the sign pi by 2 minus x. Okay, this is minus x and dx here. And now write also here cos of pi by 2 minus x here. Okay, and root over sin of pi by 2 minus x here. So see again, and this is 0 to pi by 2, and also written as a cos 90 minus x is a cos x and dx here. Okay, and this is root over sin x and plus root over cos x here. Okay, if we add it by 1 I plus I, so in the numerator are both the same here. Okay, so we take a LCM like cos x plus, okay, right now here first step, this is sin x dx, and this is 0 to pi by 2, and this is root over cos x dx here by root over cos x plus root over sin x. See, both the LCM part are same, so you take like a common, that is sin x, and there the sin x plus root over cos x here. Okay, these are cancelled, so 0 to pi by 2, and that is twice I, and dx here. So integral is x, so upper limit and lower limit is this, and this is pi by 2 minus 0. So we can write here I equal to pi by 4. So this is the answer for the question number 1. So see carefully, and this is the most interesting point which I discussed here. Now follow the second question. You can see, let us assume I, and that is also 0 to pi by 4, and log of 1 plus tan x. In my some previous video, there was a discussion about this problem. So again, I have discussed also 0 to pi by 4 here. So I apply the fourth rule. Okay, I apply my fourth rule here, 1 plus tan and pi by 4 minus theta also here. Okay, and this is here x. Okay, this is your x here, and dx. We can write 0 to pi by 4, and log of, we split the formula 1 plus tan a minus b, that is 1 minus tan theta, this is your x here. Okay, and this is 1 plus tan x and dx. We take a LCM, so you got the result like, if you take a LCM, then 1 plus tan x, and we in the numerator we do here. So log of a by b, and that is you can write here log a minus b. Okay, log a minus log b. So you write here 0 to pi by 4 and log 2 to the base z here. This is base z here. Okay, and minus and log of 1 plus tan x, and this is dx here. And now this is 0 to pi by 4, and as log 2 is a constant, so we write like this, 0 to pi by 4 here. This is pi, and written by to the base as 1 plus tan x dx. See, these and these are the same. So again, replace here as I. So I is equal to log 2 to the base and dx here, and that is 0 to pi by 4. And I here, we can shift it to the left hand side and got twice a, and here is pi by 4. So divided by 2 and got I is equal to pi by 8 here, and log 2 to the base e. See carefully, okay? This is the most interesting problem here. And now see the question number 3. Just question number 3. See carefully. As the lower limit and upper limit, their sum be 5, and given that here is a 5 also. And see the property number 8 here, a, b, and there is the addition. So easily we can prove the result. Okay, I represents as I. This is 2 to 3. Root x and dx, and by x plus root over 5 minus x here. So we use the formula that is 8. So we have right here, that is like 2 plus 3 minus x here. Okay, this is the property. Again right here 2 plus 3 minus x property here, plus 5, that is 2 plus 3 minus x here. Okay, and see carefully, this is 2 to 3 here, and that is 5 minus x and dx. We can write, and this is 5 minus x, and this is minus x here, and add it, and this also I. So we added these two parts, I plus I, and that is equal to, and 0 to 3 root x and dx by this is x plus root over 5 minus x here. Okay, again see, this is 2 to 3 here, sorry, and this is 2 to 3 here, and result is this here also. So they both the same. So adding these two part, okay, 5 minus x, and see carefully, the both the denominator part are same. So we take a single integral like 2 to 3. Okay, this is root x plus root 5 minus x here, and again see, this is root x and root over 5 minus x here. See, both are cancelled out, and this is dx. So this is x here, and this is 2 to 3. This is 2 to 3 here. So this is 1 here. Okay, this is 2i, and so I is equal to half here. Okay, now also the question number 4. Just see the system, that is minus pi by 2 to plus pi by 2. See the carefully point. This is about the point number 7. We can write. Okay, point number 7. See, minus it to plus it. We can write now there. Okay, now 4. Question number 4. That is minus pi by 2, and this is pi by 2, and this is dx by 1 plus tan to the power 4 dx. Okay. In my discussion, there was a points, if the function be even. If the function be even, so you can write 0 to n twice f of x dx. If this is the odd, then and f of minus x means minus f of x. So these are cancelled out, and the result is 0 here. So now we have to show the function, that is f of x. This is even or odd. Now we have to prove if this is odd or even. If we take a minus f of x, and then we got 1 plus tan to the power 4 minus x here. Okay, and this is the even part, so it's a even function. You can write it like now 1 plus tan to the power 4 x here. Okay, see carefully. This is the even function, so I can write 0 to pi by 2 here, and this is twice time of f of x. Okay, and this is equal to 2 times of 0 to pi by 2, and this is written like here. And also apply the property that is 0 to pi by 2 and dx by, we can write here tan to the power 4, and this is pi by 2 minus x here. Okay, and this is, we got cot, okay, pi by 2 and dx by 1 plus cot to the power 4x. And now we can this cot can be 1 by 10, and take a LCM like tan to the power 4x by tan to the power 4x plus 1. Okay, cot means 1 by tan to the power 4x, and take a LCM, and this is tan to the power 4 by 1 plus tan to the power 4x plus 1 here. Okay, now this is the I, and this I, sorry, okay, this is the I. This I and this I are added to each other, then I plus I, this I equal to 2 times of 0 to pi by 2 and dx by 1 plus tan to the 4x dx, and again this is 0 to pi by 2 also, and we got here tan to the 4x dx, and now 1 plus tan to the 4x dx here. We have taken a LCM both the, and take a single integral like that, and this is 1 plus tan to the power 4x, and have there also 1 plus tan to the power 4x and dx. Okay, both the cancel, and dx is x here, so we can write here x, and that is 0 to pi by 2. Okay, 2 into pi by 2, and this also pi, so this is twice I, this is twice I, so you can write here pi by 2 your answer. Okay, now see the question number 5. This is the most interesting function. F of x and g of x are given, and both the function f of x and g of x are continuous function and also derivable. You know that every function is a derivable, and this also are continuous. Okay. And now see, f of x and g of x are both the function given, and condition here is that f of x equal to f of a minus x and g of x equal to g of a minus x equal to a here. Okay. Right now here, given that f of x is equal to f of a minus x and g of x is equal to g of a minus x is equal to a, and we have to show this is equal to this. So 0 to a, that is f of x and g of x, and now see this is here a minus x, so that type of property will be used here. This is the point number 4, and so now let us assume this is the I, and 0 to a we can write the property f of a minus x and g of a minus x and dx here, and also 0 to a f of a minus x, and that can be written as f of x here. Okay, now g of a minus x and g of a minus x, and that is equal to a minus g of x, a minus g of x here. Okay, and this is dx, so it can be written like 0 to a and f of x into a here and dx minus 0 to a, and this is here f of x and g of x. Okay, and this is as a I, this is as a I here, so I are I, these I are 2i, this is 2i, 0 to a, and this is into a, and f of x and dx, so we can write here I is equal to a by 2, 0 to a, this is 0 to a, and f of x and dx here. So this is proved the problem number 5. And now just discuss the next problem, that is 6. Now we want to, in my previous video there was a discussion about the 6th point, and some more problem there. 0 to 4 here we have given, and mod of x square minus 4x plus 3 and dx. If we factorize this problem, this is x square plus x plus 3 is equal to 0, and we can take here x minus 1 and x minus 3 equal to 0 here. Okay, I think right factor here. So you can write here x equal to 1 and 3. So 1 and 3 at the point in between 0 to 4. So split this integral like 0 to 1 and mod of and factorize this x minus 1 and x minus 3 here and dx, and also written 1 to 2 here. This is no 1 to 3 here. This is 3, and so you can write x minus 1 and x minus 3 mod of that and dx, and also that is 3 to 4, and can be written x minus 1 x minus 3 dx here. And now see, so what is the sign? If we mod or remove, then what would be the sign? If we take any point between the 0 to 1, and like 0.5, 0.9, 0.8, something in between 0 to 1, if we put here, then you got like 0.5. We give us a negative and also a negative. The two negative signs, that what will be positive. So that's why sign B here positive. So we take a sign here x minus positive, x minus 1, x minus 3, and in the front of that positive here. Okay, now on the interval 1 to 3 here, so if we put some value like 2, 1.5, 1.3, up to 2.9, approximately in between 1 to 3. Let us assume like 1.1. If we put here 1.1, this is positive, and here is negative, and their product is negative into positive is negative here. So we can take a sign negative. So x minus 1, x minus 3, and dx here. Okay, and again 3 to 4. In between 3 to 4, let us have some value like 3.1, 3.4, any value. If we put here 3.1, and this is positive, and this is also positive. So sign B here x positive and x minus 3 positive. And this simple technique, all of students will use there and easily solve the problem. Okay, and you know the procedure of integration. So not needed to show here. So now we want to discuss about the point number 7, problem number 7, not point number 7. This is the problem number 7. See what is the problem here? There was a lower limit is there is a lower limit here is plus minus and plus a, and e to the power that is x to the power 100, and here is sin x, and now in the derivative part here is also 1 plus x to the power 2n and dx. See any conclusion about n? Yes, there was given n is an even integer. N is an integer. This is an integer. So now we want to show this type of function. What type of function is this? Which is odd and an even. So now let us take a function f of x is equal to and e to the power x to the power 100 and sin x here. Okay, into sin x here and divided by x to the power 2n. If we can take sin minus x and substitute here into the power minus x to the power 100, and also here sin of minus x here. Okay, and now minus x to the power 2n. This is 2n here. So and this is an even number, so it is x to the power 100 here. And all sin tan cos, if we apply that, the sign here is minus, so this is a minus here, and see, and this is an even number, so you always take a positive sign here. Now see, this is an we get a minus f of x, so this is the property of an odd number. Okay, odd function. This is an odd function. Okay, not number, it is an odd function. So minus a to plus a f of x and dx, and this is the property, and that is equal to 0 to a and f of x and f of minus x and dx here. And if the functions are odd, so we can write like now, this is minus f of x. Okay, and see their difference be 0, so answer is 0 here. And now another point, another problem, that is 8. This is 8. Okay, and see carefully. Okay, now repeat it. Okay, from first to second, and see carefully. Okay, now this is the problem number. This is the problem number 7 here. Okay, see 7. And now let us take us problem number 8. See, question number 8. Question number 8 here is, see, pi by 6 to pi by 3 here, and dx by 1 plus root over tan x. Again we apply the property number last, that is 8. If the lower limit and upper limit be a and b, and we can apply the point here is x, sum of the a plus b and minus x also. So in this video the property of 8 was discussed. Now again repeat the property here, and now apply the property. Let us assume as a e, and right here like now that is pi by 6 here and pi by 3, and also dx by, in place of x we can write root over tan of x in place of x. So we write here pi by 3 and pi by 6 minus x here, and that so addition is pi by 2, so pi by 2 minus x is 9 pi by 2 minus x, that is you can see pi by 3. Okay, and dx 1 plus root over cot x, it is a cot x here, and again right here this is pi by 6 to pi by 3, and 1 plus 1 by root tan x, and take a LCM, and then we got root tan x and dx here by root over tan x plus 1 pi by 6 and pi by 3. Okay, and this is I. So again added to it this. Okay, I plus I, and first integral is pi by 6 to pi by 3 here, and that is dx by 1 plus root tan x, and we got the second I, that is pi by 6 to pi by 3, that is tan x dx by 1 plus root tan x here, and then we take LCM and write a single integral like pi by 6 and pi by 3 here. So now write here 1 plus root over tan x, okay, and also 1 plus root over tan x here, okay, and dx, and this is a cancel, and this is x here, and this is pi by 6 to pi by 3, so this is pi by 6 here, okay, and this is 2i, then I is equal to pi by 12. This is the answer for the question number 8. And the last question also apply the same property, and again see and carefully see the problem, okay. This is a very interesting question, okay students. Now after this video, last problem here is the question number 9, and same property can apply. Is here, let us as y. This is I here, I is equal to, this is I here, and that is a to b, and f of x dx, and f of x plus a plus b minus x, okay. And now apply the property a plus b minus x, a plus b minus a in place of x. So again write the right here, sorry, again in place of x we can write here a plus b minus x, same as f of a plus b. Yeah, in place of x we can write a plus b minus x here, okay. And see, this is a to b here, and f of a plus b minus x and dx, and this also a plus b minus this, and this is their difference is a negative of x here, okay. And this also I, and 2i like I plus I, and I is the first integral, that is a to b, and f of x and dx, okay, and a plus b minus x, okay. Now a to b, and that is the second integral, which is same I. On the property we can write like now a plus b minus x, and this is f of x, and take LCM and we convert a same integral single integral, and that is both the same are both the same here, okay. Now f of x and f of a plus b minus x here, okay. Now see f of x and also f of a plus b minus x, okay. These are cancelled, and dx here, so, and that is a to b, we can write here b minus a, and this is 2i, so I is equal to b minus a by 2i, okay. And see carefully this video, and total video is the most interesting classes for the students, like my videos, and next discussion about these points in some problem and more problem we are post to the my channel, and see carefully, okay. Bye.